Now basically given that z equals to e to the power of I theta and z is not equals to 1, I want to show that 1 plus z squared z cubed all in z minus 1 will give me this. Alright, so here I look at it, you know how come I end up with a sign at the end? How do I show that there's a sign? So I look at this. Oh, this is actually a question that combines APGP together with complex numbers. They said, wow, okay, so it's such an interesting question. So here z answer will just be e to the power I theta because the question tell me so. So if this is e power I theta, this is probably ei 2 theta, this will probably be ei 3 theta. So I'm just scribbling some stuff to even before I see. And I see, oh actually this here is just a GP, right, where I'm looking at a summation of terms 1, ei theta, ei 2 theta, all the way to ei n minus 1 theta. And I can see that this is actually a GP, right? There's a total of n terms. Can you see like 1 and like all the way to n minus 1, so total there's n terms. And because I start from like 0 theta, then the first term is just equals to 1. The first term is equals to 1. Right, so with that, right, how do we sum a GP? Right, because we're finding the sum of this, right? So basically, we're just summing a GP. We know that the sum of GP, in case you forgot, is just A, right? 1 minus r to the power of n. Alright, so even if you want to use r to the power of n minus 1, that is fine. It's up to you over r minus 1. And from here, basically what we're going to do is going to sum it up. So our first term is 1. Our sum here is equals to 1. And here, just think of that the common ratio of the common ratio. Can you see a common ratio is just equals to e to the power I theta? Alright, so it's just a first term, right, and e to the power of I theta, like power n, correct? So this is just what is this? Is just e to the power I n theta. It's just e to the power of I n theta, right? Minus 1 over e to the power of I theta minus 1. So once we are here and then we go back to our endpoint, so wow, we are nowhere near this. Oh, and you say there's a divide by 2. What do you suspect? Alright, I'm sure you have seen this approach before and you've been taught during the tutorial that sometimes we always can take a half angle approach. And once you take a half angle approach, things are relatively quite simplified. And this is what we're going to do. We take the half angle approach. Basically, we take this portion and we're going to divide and purposely take out n theta over 2. That's what I'm going to do. I'm purposely going to take out. And after I take out, I factorize and I say, I'm left with e to the power n theta over 2 for this one. For the other one, I'm left with e I to the power negative n theta over 2. Alright, because we're talking about 1 here, so 1 is like negative times 1 here. So the addition of negative and positive powers to give you like power 0. And if you do the same for the bottom, again, I'm doing the half angle. I take out e to the power I theta over 2. And at the bottom, ei theta over 2 as well. This is factorizing this number. Alright, for 1, I'll have ei theta over 2 and e to the power negative I theta over 2. Alright, if I'm going too fast, just pause the video, look at it a while, then before you digest and go on. And that's what I'm doing. Actually, I realized, I can simplify this portion, right? And that's just going to give me e to the power of I n minus 1 theta over 2. I'm just combining this portion. And on the right hand side, you realize, well, all you're going to get, you're going to get something like cosine. I'm going to expand everything. Alright, and let me rewrite what you're going to get. I n minus 1 theta over 2. This will just be e to the power of I n theta over 2 minus e to the power negative I n theta over 2. And then this is where we really call upon the Euler's formula. E to the power I theta over 2 minus e to the power negative I theta. This is where we call upon Euler's formula. And this portion here, right, this will just be what? Cosine of negative n theta over 2, right, plus I sine negative n theta over 2. And this portion here, this will be cosine of negative theta over 2 plus I sine negative theta over 2. And this portion here, we're going to get cosine n theta over 2 plus I sine n theta over 2. And this portion here, you're going to get cosine theta over 2 plus I sine theta over 2. And that's the interesting part, because once we reach this portion, this term here, okay, we just look at how we can cancel. Usually it's going to give you something purely imaginary. And look at this portion, and I say, hey, this is just equals to the negative of I sine, because sine is an odd function, right? And it means that this and this can cancel off. This portion, cosine, is just equals to cosine n theta over 2, right? Sorry, it's not cancel off. It doesn't cancel off. It doesn't cancel off. My bad. It doesn't cancel off. Okay, in fact, it stays there. This portion here is equals to cosine n theta over 2. And because of this minus sign, right, this and this will cancel off. They cancel each other. Okay, so do the math and simplify this, and you are actually going to be left with a very beautiful term, which is just 2i sine, because you're going to be left with these two terms, and theta over 2 at the top. Similarly, for the bottom, you're going to be left with these two. These two are going to cancel out. You're going to have 2i sine theta over 2. Okay, and again, 2i and 2i cancel out, and that's what you're going to be left with. And this is the right hand side. Beautiful.